Broadcast is now starting. All attendees are in listen-only mode.
Well, hello guys, hello everyone. Here it's Ricardo speaking. I have here with me David De La Rosa, also from Telit, and Steve Sperry from McNaught and McKay. Steve, do you want to start with a quick introduction?
Sure, I'd be glad to. Thanks, Ricardo. Good day, and thanks for taking time to join us for today's discussion about how IoT is transforming automotive manufacturing. Our presenters are from Telit, the makers of deviceWISE, a transformative software product that has hardware and software edge and enterprise solutions for data transformation to help you on your journey of the industrial Internet of Things and Industry 4.0. With that, I'd like to present to you Ricardo and David from Telit.
Thank you so much, Steve. So, hello, good afternoon, everybody. My name is Ricardo. I'm Global VP for Telit Factory Solutions. And Telit is a big partner of McNaught and McKay for automation Industry 4.0 solutions. And the idea on this webinar is to show a little bit more in terms of how this technology is really disrupting the automotive manufacturing companies and what can be done with the new tools that exist. So, starting with a quick introduction about who Telit is. Telit's a global company. We are traded in London Stock Exchange. We have more than 1,000 employees spread in 36 regional offices all around the globe, in more than 24 countries, with sales, engineering, and support resources to really help customers wherever they are. In terms of connected assets, we have more than $300 billion in customers' connected assets through our IoT technology, including all the different layers of technologies that we can provide to our customers. In 2017, the company revenue was $375 million, including all the different technologies. We're here to talk about Industry 4.0 and IoT, and basically the technology that we're going to present dates back in early 2000 when this technology started to be developed inside IBM Automation Group. In 2013, Telit acquired ILS Technology and a spin-off of IBM, and we bring to Telit product portfolio umbrella basically two main products for Industry 4.0. One product called SecureWISE, that is a cybersecurity platform to guarantee secure remote connectivity to OEMs, system integrators, and service providers to many different types of factories, and deviceWISE, that is our pure IoT platform. And why IoT is changing how automotive companies are producing today. I really like this statement from Paul Krugman, where he says, productivity isn't everything, but in the long run, it is almost everything. Basically, technology exists only for a reason. That is, make sure that companies will be more profitable, more productive on the long run. And the way that Telit sees Industry 4.0 and IoT is that this is not going to be an option for customers in terms of adopting it or not. It is going to be inevitable that every single company to survive will need to use the technology that is available to really make things better, cheaper, and faster. And the numbers are here. Basically, we bring here from McKinsey the impact of IoT in terms of segments. And we can see that according to McKinsey, the biggest impact of IoT technology will happen inside factories. And in terms of applications, operations optimization and preventive maintenance are the applications that will really drive those investments and those returns. According to McKinsey, companies will reduce from 5 to 40% the costs by implementing those types of applications. At the end, companies will have two options. One that is develop everything in-house. The other one is looking for IoT platforms that will really provide the ability to do it in a more efficient way. Basically, the way that I see how companies are doing data collections and machines integration today is how things were developed many years ago in terms of in-house custom development. When you're going to type one letter, basically you have two options. You can simply go to your Microsoft Word, open Microsoft Word, and type a letter to a friend. Or you can do something that simply nobody does. That is, hire one software engineer, ask the software engineer to develop a new text editor, type a letter in this new text editor, and then send the letter to your friend. And then when your friend receives it, he's going to hire another software engineer and develop a new text editor. It's very clear in this example that this doesn't make sense at all. However, what is still happening in many, many companies is that companies are still doing custom development for data collection and IT/OT integration. And that's not efficient because companies need to invest a lot of time and resources in doing all the data collection, all the IT integration, letting them less time to really focus on what is important and what is going to make them to be more productive. That is to focus on the business logic. And with deviceWISE, this is what we guarantee to our customers. A software that provides a state-of-the-art data collection, IT/OT integration, edge computing, edge logic, and the IT connectors. So basically talking here a little bit more about deviceWISE. deviceWISE was one software created to really bring Industry 4.0 to life. Industry 3.0 is a typically highly hierarchical architecture where you make data flow always to the layer above of your technology. With Industry 4.0, you can make all the machines independently talk to each other, making the flow of data move much faster and use all the data to produce things better and faster. So basically, this is deviceWISE. deviceWISE provides you the capacity to read any PLC, any sensor, and communicate to the different levels of systems that you might have. So you can talk from a level 0 to external instrumentation. You can talk to any PLC and then move data up and down according to your necessity. Everything in a PowerPoint presentation looks pretty simple until the moment that you really walk through the line and you see the complexity of any big manufacturing facility. When you walk through the shop floor, you're going to realize that you have many different types of machines from many different vendors with completely different protocols and things that don't talk to each other. Additionally, when you go to the IT department, life is simply not easier at all. You have different systems running in parallel with different types of data inputs, and your necessity to bring data in and out from OT to IT and from IT to OT becomes extremely expensive and complex. With deviceWISE, what we do is we provide a completely transparent layer that lets you make any machine talk to each other, and not only talk to each other, but talk to any IT system. deviceWISE has three main pillars. The first pillar is the access layer. With the access layer, we provide the capacity to read any PLC, any robot, DCSs, sensors, etc. Basically, any industrial machine that companies has on the shop floor. We have a business logic layer that allows us to make any logic and make things and treat all the data that is collected. And on top of that, we have the IT connectors. So we let your machines to communicate to your IT system. Basically, deviceWISE does not depend on OPC technology, what provides us a significant advantage comparing to other solutions that exist in the market. Given our capacity to natively talk to all the machines, deviceWISE has the lowest latency that exists in the market. That will make the machines talk faster and run and improving your throughput. On top of that, we do not depend on specific operating systems like Windows. We can run in Linux platforms, Windows platforms, IBM AIX, and much more. And many other advantages exist in terms of security and speed when you are developing with deviceWISE. As I mentioned at the beginning, latency is one very important thing when we are talking about Industry 4.0. As data becomes more important, the cost of the data flow in your process also increases. If you're not efficient in terms of collecting the data and taking the decisions in real time, your manufacturing can become more complex and your throughput can become smaller in consequence of that. Comparing the latency of deviceWISE and OPC really clarifies why the manufacturing lines becomes more effective. And I can give you a real case example. One of our customers, one of the biggest automotive companies in the world, decided to replace all the OPC servers that they have in every single plant in North America, so United States, Mexico, and Canada, by deviceWISE. Only in one big plant in Alabama, by the replacement of an OPC solution by deviceWISE, we could generate more than 3,000 minutes of uptime just by the reduction of the latency. In a big plant like that one, that has a cost of $30,000 per minute, 3,000 minutes of uptime can represent more than $90 million in return on investment year over year. So going very rapidly here through the use cases. All our use cases, they respect a very standard flow. That is how you collect data. So what are the devices that you're gonna get the information, and through all the drivers that are part of our solution, you can rapidly collect the information on a click of a button. Connect the data that you collected. So bringing this data from IT to OT. deviceWISE has a full visualization package that provides you the ability to bring data through web APIs and make sure that you can create dashboards and end-on displays to visualize the data across the shop floor and through also mobile devices. The analysis is a consequence when you have your data in hands, and deviceWISE has the ability to talk to many systems that can do it, like IBM Watson, Siemens MindSphere, and many others. On top of that, you can create logic embedded in your system using our 4th generation code method by a drag and drop system that is gonna be displayed in a couple of minutes. And of course, all the system means through the improvement of the process, you can implement OEE solutions, different types of KPIs, preventive and predictive maintenance, and many other solutions to really increase the productivity. Showing one real case example here, I would like to talk a little bit about Honda. Basically, the way that Honda is using deviceWISE is a full usage of deviceWISE as the main automation tool on the shop floor. Just for one example, when this company is producing a certain part number and it's going to shift from one part number A to the part number B, deviceWISE is the system that is talking real time with the MRP and MES of the system and understanding what is the next car to be produced. deviceWISE goes to all the databases and collect what are the recipes and the movements for all the robots and PLCs through the line. It goes to those PLCs and robots, updates the recipes, and when you have the part number to be produced in line with the recipes, deviceWISE commands the line to start the line. All this without any human interaction. deviceWISE makes different brands of PLCs, controllers, and machines to talk to each other. So it's absolutely easy for you to move a data from a Mitsubishi PLC to a Rockwell PLC and to a Siemens PLC. Everything becomes absolutely transparent. All the data is collected in real time, providing preventive maintenance programs so you can count cycles, cycle times, vibration, and much more, and implement logic when you are about to expire the certain numbers of cycles and you need to ask for the maintenance manager to visit the line and to check the machine, all this is done automatically through deviceWISE. In this presentation that will be provided later, we have the link for Honda describing a little bit more of the use case that they have with deviceWISE. The second use case is with one of the biggest car makers in the world that has more than 60 plants. Basically, deviceWISE in this specific customer is being used to collect data not only from robots and PLCs, but also from simpler machines like DC2s. Of course, that one big robot or machine can be a big problem to any automotive customer. But one simple DC2 can also generate millions of dollars in a recall if you're applying too much torque or too less torque. So even those simple machines, they need to be controlled and tracked. And the way that this company is doing is through deviceWISE. So basically, deviceWISE is talking to many different brands like Atlas Copco, Ingersoll Rand, and others, collecting the data from those DC2s and providing all the traceability, car by car, VIN number by VIN number, so they can have the traceability in terms of what happened to each car. And if something goes wrong, deviceWISE can identify it and stop the line immediately if that is the case. Last but not least, we would like to show the third use case on how we are helping American Axle all around the globe to collect data from different types of PLCs, CNCs, and machines, collecting this data, putting all those data on OEs, and helping them to improve their productivity. What happens is when you can track the productivity line by line, shift by shift, operator by operator, technology helps also to transform human behavior and provides to managers all the capacity to understand what is going on and act on the bottlenecks of the production lines. Also, in this web page, we are providing the link for the video where AAM describes in details how this is being used. At this moment, I would like to ask David La Rosa to provide more details about deviceWISE. He's going to show the real live demo of the tool. David, please.
Thank you, Ricardo. Okay, so let me switch to, okay, so now Ricardo mentioned, I'm gonna be talking about, basically, it's a live demo of deviceWISE, the tool that Ricardo explained. We mentioned the OT world, which is the devices world, the PLC world, and the IT world. And what we're going to do is show you a little bit how we do preventive maintenance or simple data collection using deviceWISE. So the devices section here is where we define basically all of our PLCs. And I already had some, so I'm going to delete them. So you see this from scratch. Okay, so I already have some other ones here, but we're gonna do a few from scratch. Most of you are probably familiar with the Rockwell ControlLogix line, so I'm going to do a ControlLogix device. So I'm gonna provide the name called DemoLogix, it's just a name, and then you pick from the list of supported drivers or connectors. So this happens to be Atlas, Beckhoff, CNCs from FANUC, MQTT, CNCs that are empty connect, all the Mitsubishi line, of course, DA and UA clients. So if you have UA or DA servers, all the Omron line, just about all the Rockwell line, all the Siemens line. So basically the top, whatever, 90% on the PLC world, but also DC tools like Atlas, Apex, Clickor, IR, Bosch, and a few other ones. But for this example, we're going to show you how simple it is to define and see your OT device, your control device. So I'm going to configure this Rockwell PLC, which is at 172.27.13 245, and it's in slot 0. So throughout the product, you could press this button called validate, which basically makes sure everything is good, configuration is good, network is good. So we're going to save this, and we're going to start it. And what deviceWISE does, it goes into the actual ControlLogix PLC and retrieves the entire data model, the entire address space, controller tags, program tags, or UDT, scalars, arrays. So basically everything that he has inside, we could see. And we will use this as input into the business logic, whether it be preventive maintenance, data collection, OEE, FIS, that kind of application. So I'm going to do a couple more devices here just so that you see. I'm going to pick an S7300 Siemens device, then pick the particular model here. It's a 300 and the IP address. .243, and like we did before, we press validate, and what this does is talks to the PLC, make sure he is who it says he is, and then we save, and then we start, and then in a similar fashion in Rockwell, we go to the device and enumerate all the data blocks, and then you could read and you could write and so on. So we'll do one more, and then we'll move on, and then I'm going to create a Mitsubishi demo Q Melco, and then you go to pick it from the pull down. It's a Q controller, and then we supply the IP address. And then of course you validate again, and that means we can talk to the CPU, and then we'll do the same thing. We do a start, and now you have basically the entire address space of the PLC. Generally, people put information on the D register, on the data registers. So that is how easy it is to do a connecting to at least the PLCs. We have already pre-started an Atlas Copco controller driver instance. This is a fascinating tool using discrete manufacturing. Tier 1 suppliers and actually OEM car makers use many of these tools in assembly or even powertrain. So this happens to be an Atlas Copco, and we support them very well, actually. We allow you to pick revisions, subscribe for VIN number changes, trace information, and so on. So this is already defined and working. So this is as far as the OT or device connectivity goes. So that's step 1. That's layer 0. That's at the bottom. Now we're going to visit very quickly here the enterprise side, the IT side of the equation here. And what you see, in the similar way that we have devices in the OT world, we have something we call transports, and they're nothing more than connectors to IT things. So we have multiple types of connectors. We have a DB type for database, and then you pick the database type. So it could be in the IBM line, DB2, DB2400. It could be MySQL. It could be Oracle. It could be SQL Server. It could be SAP HANA, MongoDB, Postgres. So basically, who is who in a relational database we support. So in addition to relational databases, of course, we can connect to systems that are RESTful HTTP. We connect also to things that are based on J2EE application servers like IBM WebSphere or SAP NetWeaver. So you could deliver data into queues in any of those systems. We support, of course, Microsoft MSMQ, which is very similar to IBM NQ series. It's a queuing mechanism. It's a messaging system with guaranteed delivery. We support the entire SAP line. So SAP is worth noting because they're very popular with the preventive maintenance modules. So you could open tickets when machines need to be calibrated, for example. The same is with web services. You could communicate, say, IBM Maximo via web services. For example, SAP MII, and a later addition was IBM Watson. So if you have some cognitive or AI of analytics that IBM offers, you could then get OT data, like data from sensors like PLCs, into IBM Watson for some kind of cognitive compute predictive kind of an algorithm that is implemented up there. So basically, we support a good amount of IT systems. I would say this is in excess of 90% of any IT system out there we can access. So that's on the IT side. These transports are from device-wise to the IT system, and we have the concept of listeners, which is we listen on the IT system. The IT system then deliver us data, and then we'll take an action, which could be write a schedule for some production or recipe into our PLC, for example. So it's both ways. Both sides could be master. So this basically sort of summarizes the OT space, the control space, and the IT space. So the next step is how do we create business logic here? And for this, we have this is how we do the logic, right? For example, if this bit is set to true, then you write to a database to signal the machine is on. When it goes to false, you update that table for off, and that could be a kind of a very simplistic way to compute OEE. You know, rather simple, but you could do that. If there is a DC tool that is in need of calibration, DC tools, in particular Atlas, they have counters for diagnostics and operation. So every so many tens of thousands cycles, they have to be sent for calibration, for example. So it's very simple to do a trigger that when the threshold is exceeded, to open a SAP PM ticket or IBM Maximo ticket to schedule the calibration. So those systems know how to schedule and assign and do the spare parts and all that stuff, but it's very simple to do. So what I'm going to show you here is a very simple logic to, if some value changes, send an email, for example. So I'm going to create this project demo, and then let me see, I'm going to start it, and then I'm going to open it, and then we're going to create something that we call in device-wise lingo is called a trigger. And a trigger is just a unit of business logic. It has two parts. The top part is what we call the event. The event is specifies when this trigger is going, when this business logic is going to run. And on the bottom part, you will see actions or steps that are taken when that event is true. So this is how you do business logic in device-wise. There is no programming in the traditional sense. It's just drag and drop, fill in the blanks, and away we go. So for example, let's go back to the events. The events are we have an event engine that is actually very powerful. There's many types of events. There is an event based on data. For example, if a PLC variable changes. So if we pick this control logics, this tag, in what this event here is saying is if this value changes, do something. This is what we're going to do in a little bit. We're going to do it down here. So this is what we call a data-driven or a data event. An on-demand event is an event that you say, it's a trigger that you say, run right now. You say, fire it, or you have another trigger, fire it. That's not as interesting. A schedule trigger is very familiar to everybody. It says, this is a periodic type trigger, run it every second, every 1,000 milliseconds, very simple. But you could also be very granular and detailed when it runs. You want it to run at 8 a.m. every day except in December, for example. So you could be very granular here. And what customers use this for is maybe at the very beginning of the week at 1 in the morning, this will run and will clear some accumulators, maybe accumulators on the IT system or accumulators on some device, for example. And then another trigger that fires on Friday at say 8 p.m. when nobody's around, it will do the totals and it will, record the weekly type information somewhere, maybe on a database, or we'll send it to IBM Watson, or we'll archive it somewhere. So this is a very powerful scheduler built into deviceWISE. Then, in the case of DC tools, there's many kinds of events that a DC tool could send into us, and one is, of course, an Atlas Copco event message. When the DC tool does a tightening, it will send torque, angle, VIN identifier, whether it passed and it failed, and all the information about that rundown. I think it's about 100 items that are being delivered, so we capture all of those. The key here, though, is that this data comes in as an event. There is no polling here going on. This system is basically sleeping, waiting until the controller signals that here is a rundown or a tightening event. You could also get a trace event. If you configure this driver or this particular device to say, in addition to the rundowns, I want you to send me the trace information. In the DC tool business, trace means is the waveform, is the torque curve over time, Newton meters per 50 some milliseconds. So you'll get 800-900 points, and you could plot it and see how every fastening should be alike. If you start seeing trending and deviation, you know something is wrong. So anyhow, the bottom line here is the Atlas Copco events come in unsolicited. A controller alarm, for example, could be a signal that it's time to do calibration. So if you pick this in the trigger fires, this means that a particular controller has exceeded a threshold before a calibration needs to happen. So that's on the Atlas Copco. Just to not elaborate here too much, we also support what we call PLC logic events. PLC logic events is when the PLC is the master here. The PLC knows best when you need to know the data. So when that condition is met, the PLC then does a network transmission and sends you the information. For example, test results. You're doing a batch. There's about 20, 40 analog values that have to be sent. When the batch is complete, you put them on in a contiguous data block, maybe like a UDT in Rockwell, and then you send it as a network instruction. The advantages of this is, of course, you don't have to poll. You get all the data in one frame, atomically and consistent. So there is no data mixing because you are polling individual tags. You're getting this as a transaction. You also get lots of throughput with this. And also very little network utilization with that. So those are the kinds of events, we could go on and on, but this will give you a flavor of the kind of event engine that we have. So that's as far as the events. Now on the logic side, we have multiple categories. So for example, in the case of Atlas, and you would see another entry if you have an IR tool or an Apex Glico tool or a Bosch tool. In the Atlas, you could say, I want to select the following program. So you drop this here, and then when this trigger fires based on some event, you select a program on the controller. So this is used for like in kind of scheduling. If you are building a particular part, the MES sends you the recipe, so to speak. You could then enable the tool. You could set the tool with the right parameters to do the right operation, and then run the operation, disable the tool, and wait for the next piece of work from your MES. So this is very, very flexible. So this happens to be Atlas. So of course, you could set VIN numbers, identifier. Batch size is if you have multiple rundowns, 1 out of 8, 2 out of 8, 3 out of 8, and so on, and you know when the whole operation is complete. On the enterprise side, you could then drop what we call a transaction, and a transaction could be open a PM ticket or insert a row of data into, insert a set of data into a table, for example. And this transaction is a high-level abstraction. You could be doing a web services interaction with, say, IBM Maximo. You could do a BAPI interaction with SAP PM. You could do a relational database insert, or you could do delivering a JSON payload into some queue on IBM MQ or some NetWeaver JMS queue. But the beauty here is you only use one instruction. So basically, we make all IT systems look alike. Or we demystify. They all look like, okay, I'll do a transaction. So this is on the IT side. We have also, you know, the traditional, you could drop an email, for example. This email action, you have to specify clearly the addressing information, you know, the server address, the port, what kind of authentication, from who to who, and you could even include attachments. So if the business process is such that somebody delivers test results on a file and you have a signal, you could just attach those files and send them somewhere for archival or processing. So very, very powerful action here, networking action. You could do FTPs, you could get files, you could send files, you could do string manipulation. In the enterprise, you could deliver data to IBM Watson, for example. JSON, you could, based on some tags and a template, you could emit a JSON document that then later is used to be delivered for somebody to consume, like IBM Watson or some other IT system. What else? Bit manipulation. You know, some devices, they send you data highly encoded, like the first 4 bits is this, the next 4 bits is that. So we could use some of this function to basically take it apart, parse it, and leverage it. So I won't bore you with all the actions, but they're pretty rich, and you could do very powerful business apps with this, very simple. So what I'm gonna do now is give you an idea how you will do something like if a bit changes, you send an email for you get an idea how this works. So you say data, and we'll pick a bit. And to be honest, I don't know if they're changing or not, but let's just pick this one. And then you drop like a email action here. And that's it. So when that bit changes, we send an email, and of course, I'm gonna make this up. And the port is 25, and then authentication, yes, and then you have user password, and then from PLC OT at acme.com, for example, to plant manager at acme.com, and then you could say signal loss or something, and then that's it. This is how simple it is to do some business logic. This happens to be value change, but we could make it to be if it's equal to true or 0, then this will fire. So this is how you deploy business logic in device. Very easy, drag and drop and discover. So we're gonna save it. Clearly this is small step. I have to give it a name, demo signal email. And then you save it. And so that's basically how you would do very simple business logic that looks for a particular bit on a controller, and then when it's true or is 0, it will deliver an email to somebody. Very simple to do. So that is very simple. It could be a database, it could be any of the other IT systems that we mentioned. And then I'm gonna give you a very quick overview here, a little more complicated of a trigger. We created a small web app, which is a visualization HMI application to use our DC tool that we have here for a quick demo. So you see some trace information and how we do displays or HMIs. And these triggers are not that much more complicated. For example, this sets a job. This sets a parameter or batch size, very simple triggers. Or a complicated trigger will be a rundown. A rundown is the whole tightening. In this particular case, when the event happens, the DC tool sends all the parameters, all of them. We'll record them into a built-in relational database that deviceWISE has. And then we'll do a write to some device to signal that something came in. If you notice, you could do self-documenting business logic. So you could see what the person that did this trigger intended to do. So it's kind of self-documented. So this is already built. And what I'm going to do is I'm going to show you this as it is running. And then I'll open it for questions. Let me see. Atlas Copco demo. Refresh. So this is what you see here is a web app that you could also is web-based, is fully web browser-based, is HTML5, and the interactions with deviceWISE are done on a POP-sub way, so the network load is minimal. We only transmit when there are changes. It's a multi-client. You could have multiple clients connected to this, so you could have iPads, phones, or computers pointing at it. And then what you're going to see, well, you won't be able to see what I'm doing, but I have a DC tool here, and I'm pressing the fastening, the trigger, and you will see now that all the information is changing, right? This happens to be a process that will take 10 rundowns. So it's doing 8 out of 10, 9 out of 10. And what you see at the bottom is the torque information. So you'll be able to do repeatability or analytics in it. One of the customers that Ricardo mentioned earlier gets this data for every rundown or tightening and delivers this data for IBM Watson for analytics. So very simple web app. It's very lightweight and it's browser-based. So you could run it just about in any mobile or portable device, even a laptop. Or you could light up a big TV that is like an andon display. So that's kind of what I had in as far as a live demo. I think we have about a good 15 minutes for questions and answers. And I'm gonna hand the floor to Ricardo. Thank you.
Well, thank you so much, David. Steve, any comment from Mac and Mac?
Yeah, hi, Ricardo. Thanks again. Yes, so as you can see here on the page, we have been offered a quick spiff, a quick start package, if you will, that includes a year subscription of support and the software for up to 20 devices. That includes unlimited drivers on both the enterprise and the device side, 2 free seats to the deviceWISE University, and a year of support included. So you can contact myself, Steve Sperry. My contact information there is sperrys@mc-mc.com, or you can direct that inquiry to your local engineer for those of you outside of the Michigan area. You're certainly welcome to call me, but as you can imagine, we'll probably be reaching out to your local support teams as well to help you with that. So thanks so much, Ricardo and David. I really enjoy what I've seen, and hopefully the rest of the folks out there have enjoyed it as well. Thanks again for the opportunity to discuss this technology with our customers and our inside team.
Thank you so much, Steve. Thank you so much, everyone. If there is any question, we good to address any specific question that you guys might have.
Sure, yeah, we have some time for questions here, Ricardo. I can get to a few that have been submitted. 1 second. Let's see here. All right, so we have one question. This one came in a little bit early in the webinar, so they're asking about, what exactly do you mean by no more coding? Can you tell us some of the examples of how you're removing coding from the equation? I think we saw one example with the graphic user interface work, what David was showing us with the drag and drop, but can you expand a little bit more on that, Ricardo?
Absolutely. So basically, when we say that it's not required more coding, device-wise is one tool that was created to really simplify the process of collecting data from any specific machine, and then with the data in hand to decide about what is the business logic that will be created. As David could show during the demo, it's not necessary for you to write one single line of code to really collect data from any existing PLC, robot, CNC, or any tool that the plant might be using. Push this data to one database and then decide what you want to do with this data. For example, if you want to feed SAP, you can push the data directly to SAP without collecting any data. If you want to use any data that is today in SAP, for example, what is the next part number to be produced, you can push the data from SAP, aggregate this data into the data that is collected in the system, and all this process without the necessity of writing software. So basically, this really can speed up a lot the development of applications like this and can significantly reduce the cost of maintaining those applications.
Perfect. There we go. So excellent answer to that question. We have another one here, and they're asking, what part of the device-wise for factory offering is really reducing the latency? You had that table about the latency there. Is it the architecture or exactly what aspect of it is causing that?
Okay, and well, I can address that. The reduction of the latency happens because of the efficiency of the software to really collect the data from all the devices. There is one big difference when you're using device-wise. Basically, you're not doing pulling of data as normally is done by OPC technology. We are natively talking to the different controllers, and we can do this in many different ways. One very efficient way of doing this is using unsolicited messaging. So basically, device-wise can stay quiet, and you collect the data when the data changes from the PLC, and this happens really in milliseconds, in a much faster way than any other system. And with this reduction, you can have much more productive process, and as a consequence, you can increase the productivity of the machines.
All right, perfect. We have another question here. This is about OPC. They're saying, how does OPC fit into device-wise for factory, if at all? Do we still need OPC?
Okay, so there's two parts to that question. OPC by itself, it's just a device access layer. You have to develop the rest. You have to develop code to talk to your IT system. You have to develop code to handle when the IT connectivity is down, and so on. So device-wise has all of that built in, right? So that's one level, that OPC, it's a device access layer, and device-wise has its own device access layer, and it has all the other componentry that you need to do an application. Ready, one package, one vendor. The other aspect is if there is a need to talk to an OPC server, because the machine, it's that's all they provide. There's some DCSs on oil and gas, for example, that there is nothing but an OPC DA server or a UA server available. So what we do in device-wise is we create a device, just like you saw me do for Rockwell. You would say new, so let's just say DCS, and then you pick somewhere here, DA client, and then you specify the credentials and the addressing, and then all the tags that our OPC server exposes are now part of the device-wise kind of ecosystem, and you could build business logic that way too. So not only we have our native drivers, they're coded bare to the metal at the Telegram level, that's why the speed, but you could also leverage existing OPC, DA, or UA infrastructure and bring that data into the device-wise environment.
All right, perfect. All right, hopefully that answered the question. You can always follow up with us either in the chat there or on our Telit Contact Us pages. let's see, but maybe one or two more questions we'll do. It seems like we have a little bit of time, and then we'll give back some time to the audience. This one, I have some pretty old legacy machines. Not sure they can connect to deviceWISE for Factory. Would be interested if they could. So do we have any solutions for legacy machines?
So when you say legacy machines, I have to assume that there are machines that maybe they have a serial port, maybe they have nothing. They're just machines that don't have serial or Ethernet. They're legacy machines. So we have a mechanism to bring that. If you need external sensors, of course, but we have a mechanism that you will basically put this sensor on this machine, say on the power source. So when the machine is cutting, the current level goes higher and we'll detect that. And when it's not cutting, then you'll sense that, okay, there's not enough current, so it's a 0. So we have something called the Atom Box. The Atom Box allows legacy equipment, not necessarily legacy equipment, but equipment that is not easy to instrument. For example, pumps, DC motors, stuff that is not workable, not yet at least, and then you could put a sensor to detect when it's on and when it's off. And what the beauty of the Atom Box is that it has the smarts internally that is always sensing this, but informs device-wise on a differential way. So you could connect ton of sensors, and the load on the network and on the CPU is minimal because we only get differentials, and then we'll act on it. So if it's a state transition 0, 1, you hit the database like for FIS or OEE for machines, for example. Not necessarily metal cutting, but it could be pumps, DC motors. I've seen them used to basically monitor simply it's on and it's off. It's on and it's off. But it's off the shelf, easy to plug in, and incorporates easily into device-wise.
Perfect. All right. So it looks like we have a solution for him as well. Awesome. Well, I suppose those are all the questions that we have so far. Again, if anybody wants to submit anything else, of course, you can always do so on the Telit website. I guess we'll pass it over to Ricardo, perhaps, for any last comments.
Absolutely. Thank you so much, Chris. I just would like to say that I appreciate for everyone that could join this call. I also highlight the partnership that we have with McNaught and McKay in Detroit region, and certainly they can support with all the commercial and technical support also there. For any questions, we are always with our door opens and look forward to have more interesting conversations with you. Thank you so much and have a good afternoon.